Hey grade 6, got another experiment for you guys today. This time, we're going to be demonstrating some really important properties of the atmosphere around us, the air, as would make sense in a air and aerodynamics unit, while also making a really crude approximation of something called a diving bell. A diving bell was a device invented in 1531 which let sailors go underwater for long periods of time and explore shipwrecks to collect treasure without, well, dying. It was a way for them to bring oxygen with them hundreds of years before the invention of more advanced scuba sort of things. So how did they do it, and how is this going to apply to us? Well, we're doing this with the experiment liquid versus gas, which is just water versus air in this case. And we're going to see if we can find a way to use an open container. We're not going to seal anything here, to keep things dry underwater for a long period of time. So the materials you're going to need, and I will run through them with you here, are, camera down, a large tub of water, as clear as you can possibly get it. When looking around my kitchen, I discovered that I am not classy enough to have an all-the-way clear bowl, but this Tupperware with some little swirls on the side will have to do. You can see through it, that's what matters. Also, in our list of materials from the experiment write-up is, let me put this in view of the camera, a small cup. This is just a little glass. I believe it once contained a Costco tiramisu, and they packaged them in these glass containers, and that's nice of them. So I've got one here. The third thing we're going to need is a floatable. A floatable is anything that can float. If you have a ping pong ball, that's great. If it floats well, it's a floatable. I have a little bullet bill here. Bill is hollow, full of air, and will float if placed in water. Not going to do that right this second. You're going to see it in a moment. But we've got Bill. Bills are floatable for the purposes of this experiment. We're also going to need a scrap of paper, which I have right here. This is a list of things that once upon a time I needed to buy to do a different science experiment for chemistry. I don't need that list anymore. It's still sitting on my desk with my other science things, so let's wreck it today and make it part of this experiment. Okay, we're going to run through the procedure here. Now in this case, we don't really have a control the way that we have for other experiments because we're just observing the effect that our materials are going to have on each other, specifically when they interact in this way. We're not interested in a different interaction, so we don't need a control for it. Now, let's run through. Our first step is to fill our large bowl half or more with water. That part I did ahead of time. I have a bowl of water. Hooray! This bowl is more like 3/4 full, just because I know that it's big enough and wide enough that I'm not going to overflow it while I do this experiment. If you are at all worried about overflowing, don't fill your bowl up that far. Keep it at a level where you're not going to make a huge mess by doing this experiment. Alright, step 2 is to float our floatable, in this case Bill, in your case, I don't know, a ping pong ball would be ideal. They're great for this. Float your floatable on the water. Godspeed, Bill. Okay, Bill's off doing his thing. He's having an adventure. He's swimming. Everybody's happy. He might be singing to himself. I don't know. I can't hear him. Our third step, though, is to smother poor Bill. We're going to take our cup. We are going to put it over him. And we are going to force him down into the water. Now, there are a couple of things to notice here. One of them is how dry Bill is staying inside the cup. The other is the water level outside the cup that rises as it goes deeper in, as Bill dives. Alright, so record observations about water level, about sounds, about maybe that bubble that escaped the cup and made a blub into my microphone. What did you notice when Bill went down there? And now that Bill's up, we're going to pull him out. He's a little wet down here on the bottom, but actually everything up top is still bone dry. Now you can't feel that through the camera, so you're going to have to take my word on it. Bill is totally dry on top. It's only the parts that were actually touching the water that got wet at all. Just as much of Bill is wet now as when he was at the very bottom of this bowl. No extra water was added, and nothing got wetter than it is right now. Okay, let's remove Bill. You've done a great service to your country today, sir. You can head back to the towel. While Bill catches some sun and recovers from his role in this experiment, we're going to try part 2 here. And that's to repeat the last steps, but instead of using a floatable, a bullet bill, a ping pong ball, or whatever you got, toy boat would be great, as long as it fits inside a glass. Instead of using one of those, we're going to use just a crumpled up piece of paper. And that means my old science supplies shopping list. Just so you know, I no longer need litmus paper, Pyrex flasks, a hot plate, some example chemicals, and goggles, because that was for grade 5 chemistry. I don't need it here. So I'm going to crumple up this piece of paper, pretend it's some important secret message that I might want to recover later, and then, like all important secret messages that I might want to recover later, I'm going to throw it in the water. Now, it's floating. It's fine. It will eventually get soggy and sink to the bottom as water permeates the paper, but for right now, it's not too bad. What we are going to do now, however, though, is try the exact same thing and see just how dry this paper stays. Cover it up and send it down. Now, this paper is now 100% underwater. It is below the surface. There is not a bit of paper that is poking above the water level. But its shape has not changed at all. The folds, the creases, the whatever, they're exactly the same as it was when it went in. Hopefully you can see that there. In fact, it's now touching the bottom of the container. But it still looks pretty dry. There it is. Let's let it back up to the surface and see what it looks like. Come on up, water. Come on up, paper. Oh no. Oh no. Oh no. Well, this is now a control. We'll use this as an opportunity. This is now a control for what happens to a piece of paper when you bring it all the way underwater and it gets totally soaked. Good thing I didn't need that secret message back. Let's try it with a different one. Don't need this list from that booklet anymore either. Okay. Well, now we've got control paper and we've got experimental paper. Works for me. Let's try the experiment part. So it goes down. It's completely submerged once again, and this time I'm not going to let go of the glass as I raise it up. Oops. And there's no change. This piece of paper, except for the part that was directly touching the water, is bone dry. If I unfold it, this little corner here, where it was actually touching the water, is wet. The rest is just as dry as it was when I put it in the water in the first place. Nothing happened to it. Compare that to this piece of paper, which is obviously a lost cause at this point, and there's a big difference between them. Now that difference is entirely caused by that air that came down with the paper when I brought the cup down with it. So, for your observations purposes, it is possible to submerge something completely underwater while keeping it dry if we use these techniques. It was all the way under. There was no paper at all poking above the water, but when I brought it back up, no problem. Now we'll go a bit more into the why of this. The why is pretty simple. If you paid attention at all in today's class, you probably have a good idea as to the why. but just in case, we will go over this again in class to explain the why in further detail, just in case you need it. But for right now, this demonstration of air versus water, air wins, is kind of an interesting one that relates really strongly to our current study in science. So I hope that helped. I hope if you needed to, if you didn't have something that floats and a cup handy in your house, you have been able to get the observations you needed from the science experiment, and you're ready to go. All right. Thanks, grade 6. That's it. Peace.